Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is spiral matrix. Given an M by N matrix, return all elements of the matrix. Return all elements of the matrix in spiral order. Okay. I have a couple of examples here. So if you have a matrix like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, the spiral version would be to go across the top, down the right, across the bottom, up the left, and then make a right turn, inside the matrix. Same thing here, example 2, across the top, down the right, across the bottom, up the left, make a right turn, you're inside, now you're in the next level of the matrix. These are pretty simple examples. The matrices can actually go up to 10 by 10. Okay. A couple ways to do this, probably both almost equally efficient. I mean, one of them, I think you might need a second matrix, so it would be less space efficient. But I mean, one way you could do it, let's say you had a second matrix and you go, every time you process a cell in the input matrix, you update the second matrix, which is a Boolean matrix, to indicate that you've seen that cell. So when you go across the top, down the right, across the bottom, up the left, and then once you get back to 1, your matrix, your extra matrix is going to indicate, no, you've seen that cell, the cell with the 1. So you need to make a right turn and go into the matrix. The other way of doing it, which is the way that we're going to do it, we're not going to use a second matrix, but we're going to go across the top and then increment the top index. We're going to go down the right and then decrement the right index. We're going to go across the bottom, decrement the bottom index, and we're going to go up the left and decrement the left index. After which we'll go into the next matrix, the next nested matrix, if there is one. So let's see how this would work. I'm going to move this over. I'm going to move this over so we have more space. First thing we need to do is set our indexes for top, bottom, left, and right. So the top index is initially 0. The bottom index is initially, all right, let's think about this. This would be, so it's matrix, it's the matrix length minus 1. We need an index for the left. The left is initially 0. And then we need one for the right. And the right would be matrix. And we can just pick, you know what, I should look at the constraints here and make sure that we're not going to have to maybe process empty matrices. Okay, so everything is at least 1. No empty matrices. All right, so that's good. Let me scoot this back. All right, int right would be matrix 0 dot length minus 1. All right. Now we can go into the loop and we'll say while the top is less than or equal to the bottom and left is less than or equal to right. We're going to keep going. All right. First, every time through this loop, we're going to process the top row, the right column, the bottom row, and then the left column. So first, top row. Print the top row. For I equals left I less than or equal to right I plus. Actually, I see I'm missing something here. Okay, this actually returns a list of integers. So we need a list of integers in order to return the result. List integer result equals new array list. Okay, so we'll say result add, and what we're going to add is the input array matrix, and the indexes are going to be top and I. Okay, that's good. And then increment the top index. Whoops, top plus plus. All right. Next is going to be maybe somewhat similar. I don't know. Let me just copy this. See, copy, paste. All right. We're going to print the right column. So we'll say for, oh, you know what? This needs an int here. I'm sorry. For int I equals left. This one for int I equals top I less than or equal to bottom. This is the right hand column, I plus plus, and we're going to add matrix. The indexes will be I, which is the column, and then right, which is the index of the right hand column. And then decrement the right, that is, move it in towards the center. Okay, look at the examples again. All right, once we process the top row, we're going to increment it. Once we process the bottom row, we're going to decrement it. So it is possible that top and bottom will wind up being the same. Same thing here. Top and bottom may wind up being the same. Okay, it's also possible as we loop through an what can we call it? Like an internal matrix that is not the outside rows and columns, but inside rows and columns. So every time we process one, we're going to increment top, we're going to decrement bottom, we're going to increment right, we're going to decrement left. They could be the same, but at some point in the process, top could actually become greater than bottom. I mean, if they're the same, now in this case, if we decrement, let's see, example 1, if we decrement top, it's going to go to, or I'm sorry, if we increment top, it's going to go to 1. If we decrement bottom, it's also going to go to 1. Yeah, we want to process that, but you know, that's the 6 and the 7, but in processing it, we're gonna increment top. See, now top is going to be greater than bottom. Decrement bottom. I don't know if we're gonna get that far. I've got to see how this works out. But we do have to check and make sure that the top and bottom indexes haven't crossed. We also have to do the same thing on the left and right and make sure that the indexes haven't crossed. So, in this case, let's do this. Let's say if top is still less than or equal to bottom, okay, can I paste that again? Yes. Whoa. It's going to go here. We'll say for if top is for int I equals right. Where are we now? We're on the right-hand column. For int I equals right, I has got to be greater than or equal to left I plus plus, and then put that in. Result, add matrix. That would be at bottom I and bottom decrement the bottom index. So again, it's just if we've already processed this row as top, we don't want to process it again as bottom. Again, that would be something like in example 1 here, where after processing the outer matrix, top and bottom are the same. And once we process 6 and 7 as top, we don't want to process it again as bottom. All right, this is going to be the same thing for left and right. So let's do this. If left is less than or equal to right, we'll say for int I equals bottom. And what are we processing now? We're processing the left column in a spiral manner. So the left column is processed bottom up. For int I equals bottom, I is greater than or equal to top I plus plus, and we'll add matrix I in the column which is left, and the left column index, we're going to increment it. Okay, then somewhere in here we need a return, so that would be after the while. After the while. So we'd have to return result. Okay. don't know. I feel like maybe I rushed that a little bit, but let's try it and see what happens. Runtime error. Okay, yeah, I did rush a little bit. All right, that's not supposed to be an increment. So what are we processing here? I is going to be, so if we're processing the bottom row, we actually have to decrement I, not increment I. All right, run it again. Yeah, probably this. Yeah, if we're processing the left column, again, it's bottom up, so we need to decrement I. All right, let's go. All right, so that's accepted. That is accepted. Basic test cases. Let me move this over and submit it. And what do we have? Why is that thing in the way there? Runtime, 0 milliseconds. It took no time at all. That's interesting. Let's see. Sorry, there are not enough accepted submissions to show data. Really? Okay. Well, anyway, that's the solution. You got a matrix. You want to print it as a spiral. It just set your initial indexes. Process top row. Right column, bottom row, left column. Each time you process a row or column, then you decrement or increment it. Decrement or increment the index in order to move it towards the middle. Okay? So each time you'll move to an internal matrix until you run out of nested matrices. And then you're done. So that's it. Feel free to like, subscribe, and see you next time. What is the complexity? It's n squared, right? It's got to be, m times n. I'm sorry. It's m times n because it doesn't have to be a square matrix. Okay. All right. See you next time.